Hi guys, welcome to the 6th episode of Score Couch, where we talk about technology, where we talk about digital, where we talk about backend, front-end, UX, UI design, basically everything that has to do with the tech world nowadays. My name is Olaf, I'm one of the co-founders of Score Digital, and with me today is Jacek.
Nice to meet you. So I work with Score for over a year now as an infrastructure engineer. So my core tasks are related to creating and maintaining infrastructure for the projects that Score Digital is actually working on.
Okay, so you are a DevOps.
Yes, so the official name in the contract is DevOps engineer. However, let's be sure that DevOps is actually the culture. So what the DevOps culture means is that the infrastructure guys, the old weight admins, are actually mixed with the development teams. So the development team knows from the very beginning that they will be creating and maintaining the application. So with the DevOps engineer or the infrastructure engineer as a part of the team, we can actually exchange expectations about the application. However, my core responsibility is mostly related to infrastructure, making sure that it's scalable, it's highly available, and so on, and also helping the development team with the requirements that often clients don't know they want to have in their applications, non-functional requirements that needs to be there in order to run the software smoothly on production.
Okay, a lot of terms. Infrastructure, meaning?
So with infrastructure, I'm mostly focused on cloud infrastructure. So this means that in Score we don't have any physical servers. We are not running our own infrastructure. We are buying everything from AWS in current projects, mostly from AWS. And this means that we are creating, as the DevOps team, we are creating code that basically goes to AWS, orders resources like databases, servers, and so on, load balancers. Then it connects it all together in order to create the infrastructure for the projects that we are hosting.
Okay, so couldn't this be done all by the backend developer or anyone else?
Yeah, probably there is this catch about that cloud is a lot easier and developers can do it. And that's true to some extent. So if you are starting your application and you want to have test environments, it's good to give the freedom for developers to actually play with the cloud and create their own infrastructure. However, when you go to the production areas and you want to have application that is working 24/7, then there are some gotchas, right? So developers are focused mostly on learning their frameworks, their languages, and how to create the best possible code. However, they are not thinking about what can go wrong on production. And trust me, there are a lot of stuff that can go wrong on production. So this is where the infrastructure engineering comes in. So if you have server, you don't think about one server, but you think about the fleet of them. So you have redundancy, you think about scalability. So if you have few customers and probably you'll have just few testers in the test environment, it's really easy to have your application running. However, if you go to 100, 1,000, maybe 1 million customers, you need to make sure that infrastructure will be able to grow up to the potential of the application. So this is where the knowledge of purely infrastructure stuff comes in. And this is what we are focusing on as the infrastructure team.
Okay, so I'm wondering, how do you become a DevOps? So is it something that you learn from scratch? So you are a junior, first you run your own virtual machine, then you start with your own first database and so on? Or you need to have a development background, or it differs depending on the path?
Well, the real answer is I don't know the answer to your question. Okay. I don't know how to become DevOps. The truth
but you
is,
did, somehow.
I did. So my path was that I started as an intern being a developer. And for first year or 2 years, I was doing maintenance of the big application in big corporation. And at some point, I shifted towards more of the system engineering role, becoming an admin. And with the development background, it was easy for me to jump into the DevOps world. And the difference between those admins that we have, usually every company had their system administrators division. And with this organization, you had guys that were focusing only on maintaining servers. And with DevOps shift, and especially shift to the cloud, a lot of stuff that was done manually in the past can now be scripted. We have a lot of tools that can do a lot of stuff for you. So the development background is something that is really essential to become infrastructure engineer in the cloud environment, and this gives you a lot of also knowledge about how the application is built and what you can do to make the application run smoother and better in the cloud.
Okay, I have my own Azure certification.
I love the certificate. So
yeah. I have my own Azure certification, and I have to share that in the past I have successfully started a virtual machine. I have successfully probably connected this with a database, and I even probably ran some SQL database or SQL server, maybe even Windows server, and I was not writing a single down in a command line or anything else. Everything was point and click.
Yeah, that's true.
So can I be DevOps?
Probably an intern or maybe junior.
Okay.
So having experience with the cloud is something that is really great. However, a lot of those tools and a lot of presentations that you will see about the cloud are related to how easy it is to click out the infrastructure. However, if you think about having development, QA, maybe certification and production environments, it means there's a lot of clicking in order to get those services or infrastructure up and running. So I have experience with company that actually had this short videos, like 2 or 3 hours long short videos, where somebody was going through the process of creating infrastructure for a particular application. And this is not what you should be doing, in my opinion, when you are thinking about large-scale applications, maybe microservices, and you have not only 4 environments, but also 100+ applications. It means a lot of manual work. Instead, you can use tools like, for example, Terraform, where you define the infrastructure and tell the tool that it should create the resources that you require. Especially that with the cloud, we must remember that a lot of stuff can go down in the cloud. You are not paying the money that you would pay for creating your own data center. You're not paying up front, at least. So you must expect the infrastructure to go down. And when it comes to servers in the cloud, having more than 1,000 servers under maintenance, we noticed that about 2% of them just turns off every month. So you have to recreate 2% of your fleet of servers. And well, this is not ideal if you have to go every time and click out the server configuration.
Sure.
So this is where all the tooling comes in. And for small projects and maybe test environment, it is really good to have this opportunity to go into the UI and click it out. However, for larger setups and maintaining the larger setups, it's a lot easier to have some kind of script that will just launch the entire environment in a couple of minutes.
Okay, so talking about infrastructure, you've mentioned that some of the servers, usually go down, over an extended period of time. So shouldn't they be online constantly, as you are paying huge chunks of money to Google, Amazon, or Microsoft?
So with clouds, you usually don't have this kind of SLA. So they're telling you that you should have the AMIs or any tool that will help you spin the servers, because, well, even if you buy the server and put it in-house, it won't last forever. So of course there are techniques that you can use. For example, you can use the servers that are up to 3 years old, and you have quite a lot of uptime for those servers and pretty low potential of any failure. However, in the cloud, you don't get this kind of SLA. And with the cloud, often people think that, okay, if I'm going to the cloud, it's exactly the same as my individual server room, however, it's in the cloud. It's not the best approach. So I believe that if you are going to the cloud, you should utilize stuff like, for example, auto-scaling. And with auto-scaling, if you want to have more servers automatically scaled up, you need to have some kind of tool that will add those servers. And if you think about the cloud this way, that it's auto-scaling and constantly dropping the servers and adding new ones, then you must think about the SLA a little bit differently. So you know that you will have few servers up and running at the particular time. However, individual uptimes of the servers is not that important. So unfortunately, cloud is not giving you much of the SLA, and you should build the application so it will be resilient to this kind of failures. And to be honest, it's not that complicated to create application this way to fit the cloud. However, it's really good to have this expertise and this idea that the application will go to the cloud from the very beginning of the development.
Okay, and I'm wondering, what's the size, or what's the what's the size of the project that should have a person like yourself, so a DevOps, looking at that while being shipped to production? Is it every application? Is it something that has 1,000 users, few 100,000 users per day, or how do you assess the necessity?
Well, in this case, it's quite complicated to answer this question, because the best scenario would be to have an infrastructure engineer looking at every single application that you want to go to production. But the truth is that, well, having additional people in the team is not something that especially young companies can afford. So a lot of startups actually just go with a little bit YOLO approach. So they just push to production and hope that it will not crash for at least the beginning. So if you get the traction and if you get funding or you get the revenue from the application, it's good to have someone to check if you will not lose the data in next month or two. So that's important to check. However, for the small companies and for small projects, it's pretty okay for developers to do the infrastructure part, or even use services like Heroku that will do most of the heavy lifting for you. They are not the cheapest ones, so it's important to at some point switch to the infrastructure team and create this infrastructure in the cloud. However, for the very beginning, it may be something life-saving, because you know how it is for small companies, right? You have really tight budget, and every additional hour spent somewhere else is not worth your time. So this is why in the beginning maybe you should look on the solutions that are self-serviced. Then when you grow a little bit more, you should consider moving to the cloud to have flexibility in terms of how much you pay for the infrastructure, also with all the benefits of having infrastructure tailored for your application.
Okay. Is there any let's say a set of good practices or a beginner's course that you can do in order to have the, let's say, the basic knowledge? Because I know that clouds, I mean, meaning like the majority of the providers, like the biggest ones, are constantly changing. So is there something that you can have in place? You've left at the certificate earlier on in order to ensure that you have the basics covered?
Well, I believe you don't need a certificate. It's definitely a good way to make the learning curve a little bit more smoother, because with certificate you get those materials, you get a lot of feedback how you should learn about the cloud. However, in many cases, it's all about how much you've seen. So the thing with infrastructure is actually a thing about experience and learning from the mistakes, and you don't want to make those mistakes in the very beginning. So if you are someone who wants to become an infrastructure engineer, my recommendation would be to find the company where there is actually an infrastructure team and just tag along with them. So you will learn a lot from the guys that have more experience. You will see a lot of stuff that's going on. Maybe you will also be involved in some kind of incidents and so on. So those are the opportunities for the infrastructure guy to actually learn what was done wrong, how the system crashed, and what can we do to prevent it. And that's, in my opinion, the path to becoming a successful infrastructure engineer. And all the knowledge that comes within, so the cloud knowledge and so on, I believe that you will get this knowledge along the path. So it doesn't matter which cloud. If you know how the system works and when it breaks, it's a lot easier to apply this knowledge to what you can see in cloud. However, on the other hand, the clouds are also a little bit different beasts than, well, maybe from one another, or even from having on-premise data centers. So it's also good to focus on single cloud. So I had experience with AWS, some with GCP, really little with Azure, so I will probably asking you some questions about it later. However, I noticed that, well, if you try to make those perception that those clouds are similar and they offer similar services, it's not true. And if you want to be like multi-cloud, which we did for a while, it means that either you will have to use only the subset of functionality, really thin subset, or you will have to create a lot of tooling to support two different approaches to the same problem. So it's good, especially in the very beginning, to focus on one cloud and to learn all the strengths and weaknesses of this particular cloud, and make sure that the solutions that you are delivering are tailored for this particular cloud.
Okay, so that seems to be pretty interesting. Okay, so very simple one I think I have for you. Why do you even go cloud nowadays? Why not stuck with good old on-prem? You can just buy your server, put it in your office, plug it into the socket and wait for magic to happen.
I found a lot of companies that actually try to do it, and especially with startups or small software houses, they usually buy like $2,000 machine. They just plug it in. They take internet provider, connect it in, and they say, okay, we have a server, we have
a data center.
Data center.
They have data center.
Exactly. Now, the problem here is that if your power goes out, then your production server is offline. And okay, you can buy UPS, but what with the internet, right? If there's maintenance, you are offline. If something breaks in your computer, maybe a hard drive, it's usually not hours, it's more like a days to actually find the replacement and install everything from scratch. The second approach is to actually build a real data center. However, it's not cheap because you need to have professional servers that have redundancy. You have to have redundant power lines, redundant internet connections, and so on. So this is really huge upfront cost. Now, if you are just starting, then again you are looking on the money. And with cloud, you actually pay for what you are using. And if you do it right, then in the very beginning, you can pay really little for the infrastructure, and you are prepared for this massive increase of traffic. You will just from one night to another pay 10 times more for a lot more revenue. So you can afford to have this at particular time. Now, for the companies that are starting, this is really good approach. With moving to the cloud from on-premise, it's usually a lot of hassle because first of all, you have to pay for moving the data. You pay for data in and data out of the cloud. And then you have those servers that, well, you have to throw out. So for many companies, it's not that easy to migrate to the cloud. But if you are already there, it's a lot of potential for playing with scalability of your application. So if you, for example, have a business that during the summer season gets like 10 times or 100 times more traffic than in the winter season, you can have 10 times more servers only for the summer season. And pay only for those servers during the summer season.
And for that period of time,
yeah. So that's the huge benefit. And you need to plan the application to work in this particular way, so be able to auto-scale. But if you do it, then you can even decrease the cost of running your applications in the cloud. But you need to think about it during the architecture period.
Yeah, going to the architecture period and building the bridge. While developing, while building, while planning, where do you think is the best moment? When do you think is the best moment when infrastructure engineer should speak with the development team?
Well, from the very beginning. So it also depends on how the team is mature and how much knowledge about the cloud they have. However, the cloud knowledge is really important from the very beginning. So when you think about the projects, usually customer comes in and says that I want to have this functionality and this functionality, and most of this is focused on the customer of the application. Nobody thinks about I want to have this data redundant, I want to have this done that particular way. Everyone is thinking about the value for the customer. However, from the very beginning, you should be thinking about how to deploy it and how to scale it up. So in many cases, you can do some infrastructure and development magic. So instead of application crashing on the really heavy load, you will just have the spinner for 2 more seconds and it will all work out. But this is something that you need to plan on the very beginning, where you are creating the microservices, when you are deciding what should be synchronous and asynchronous call. Also, what should be a REST API and what can be the worker over the queue.
So what does it mean to have synchronous and asynchronous?
So basically this means, well, if you are the customer of the application or the user of the application, then you interact with some kind of the front end of the application.
Sure.
And with every click, there is actually a request to the server and you are waiting for the response from the server. And this is synchronous way of communicating. So on the back end, there's always a thread dedicated for your connection that's doing the work and immediately returning it back. Now, that's must have for facing the client or the user of the application. Mm-hmm. However, when we design microservices, they are often talking to each other. And in here, you don't need to have this synchronous way of communication. In many cases, you just have to notify other service that something changed with the data. So instead of doing the synchronous communication, which can be really expensive and lead to other problems with the design itself, you can just push the message on the queue, and when the second system is ready to consume it, it will just pull the message from the queue, update something, and do the action on the asynchronous message.
Okay, so the communication should happen from the very beginning. Is that the conceptualizing phase when developers? Oh, that's actually a very valid question. So should developers be responsible for conceptualizing the infrastructure of the product?
Well, I think
I'm thinking about the relation between back end and front end, and how do you do it, when do you do it, and so on. Or should an infrastructure engineer should be involved also in that part?
In this particular area, I think it's split responsibility. So the infrastructure team can give you a lot of hints what you can use in the cloud, and in some cases even give you some hints how the architecture should look like from knowing the business cases, what can be, for example, asynchronous and versus synchronous. However, the thing is that, the developers are mostly responsible for creating the code and making sure it's not only working properly, but also really easy to read and maintain in the future. So you need to have this cooperation between the teams, and this is when the DevOps term comes in. So DevOps is not about having the group of DevOps engineers. It's all about having this culture of people talking in the very beginning of the application, so that the infrastructure guys know exactly what they will be running and where are the weak points and what can they do in terms of infrastructure. And the developers also know how to structure the application so the infrastructure will be clear and the model, the design will be clear for them to maintain in future. So this is when the DevOps culture comes in, and this is something that boost up the productivity of entire team and entire company.
Okay, and I'm wondering right now, during the development phase, we have the people that are involved have multiple environments, right? That they are developing, they're testing, there is a production environment. What kind of role does infrastructure engineer play in that part?
So in the very beginning, when we are creating environments like, for example, development or QA, first of all, we need to make sure it's corresponding production as much as possible. So the best approach would to have actually the same environment, the same sizes and the same data on your test environment. In many cases it's not possible because, well, we don't want to have customer data on test environment. However, we try to mimic the environments as much as possible. So we use the same databases, the same versions, we use exactly the same components. So starting from the very beginning, when developers are starting their first test environment, we are already coming in with the tools and the frameworks that we'll be using on production. So we have exactly the same setup for development, QA, certification, and production environments. So if you want to spin one environment more, then we can do it exactly the same way it's done on production.
Okay, so we are pushing to production, it's ready, boom, done. That's it, right? It is out there and it's auto-scaling, you know, you have all of those mechanisms implemented, right? So your role is done, right? You don't have to do anything else.
There are those memes on the internet, especially when there's a building fire and there's this cute little girl saying that it worked on dev and it's ops problem now. And this is a huge problem, especially in big companies, that you have this ping pong. So developers created application, it went through the QA testing, it was signed off, then it goes to production and it's ops problem now. And if the application crashes, it usually crashes in the middle of the night, then it's ops problem to bring it back up. Now with nowadays with the DevOps idea is that the developers are also responsible for production. So there are so many moving parts in terms of infrastructure and development that there is no chance that you will get it right the first time. When the user comes in, even if you tested the application really good, the user will find a way to break it, and that's, well, that's how the world works. Okay. And in this particular scenario, if you have the dedicated DevOps team or dedicated administrator teams, the ops team, they will probably restart the application, try to do some magic, maybe even break it further if they don't have any feedback from the developers. And in many companies, the developers at this point are saying, it is not our problem, we have those features, there's a deadline. So the application is not working, but at this point, it is not our priority to fix it. With the DevOps approach and mixing the infrastructure and developers, if it crashes at 2 a.m. On production, then you are calling the developer to help you out with solving the problem on production. And he's a lot more motivated to fix the issue with the code, so it will never happen. So especially during the first few weeks or months when the traffic actually comes to the application, it's really good to have the same team that designed the application and wrote the application to help up with support of it and fix all those small problems that can occur, maybe some database log, something that happens with the scale. This is something that they can fix immediately and we can have smooth running experience for the customers.
Okay, so from my perspective, I just, you know, reach out to my phone, I just click and it works. And in the background, it seems that there are busy bees making it all happen. So this will continuously, you know, function and work in a proper way. Exactly.
And infrastructure and the cloud actually can help a lot with it. So in classical model, when you have on-premise server rooms, if you have more customers and if you have any problems with hardware, you need to do a lot of manual stuff. With cloud, you can just say that I'm buying this particular software as a service. For example, with database, you don't care about database servers. You want to have the database up and running. So you just set up the service for the database and you are pretty sure that the cloud will make sure that it's up and running for you. And yeah, if you go with the cloud, a lot of those bees can be actually automated and moved to the cloud.
But not all of them? Because
not all of them, because still the people that created the application, created the infrastructure, this is in many cases a lot of moving parts. So yeah, they are working together to make it up and running.
At least they should work together.
Yes, at least they should.
Do you think that's the case on the market?
Depends on the company. So there's a lot of traction about the DevOps culture. and a lot of companies try to implement it. And well, it is with us for like 10 years or so. So a lot of companies actually manage to do those mixes. However, I still can see companies, especially the big ones, the corporations, where the change is not that smooth, because you often have some external company that is taking over the responsibility of the servers themselves. So you will not be able to do the DevOps with them because it's external company and, well, they are paid per hour or they have some kind of SLA. You sometimes have the system engineers, that is completely separate group that will do some tests and help you with the engineering. However, they are not working with the developers closely. So I see a lot of traction towards the DevOps direction, and a lot of smaller companies, maybe mid companies, actually are working with the DevOps teams and with the DevOps culture, and this is great. But still, there are some companies that didn't have enough time or didn't have enough motivation to go into this direction.
Okay, that's interesting. How do you feel about cloud and on-prem going hand in hand? Is that because you have a lot of those companies, especially the bigger ones, the ones that were on the market for years now, that they have some legacy software, right? They do have some legacy infrastructure, and at the same time they are launching new projects, new branches, you name it, and they do have cloud. So how do they talk to each other? How do they mix? Is it a good mix?
Yeah, so the hybrid cloud is not something trivial. So definitely it's an option, and if you have 1,000 servers in your server room and you want to gradually move towards the cloud, definitely having the VPN tunnel and having this hybrid model is something that you can do, and well, it will work. However, what I noticed when we were a multi-cloud company and we had AWS and Google Cloud, both were clouds, so it should be a little bit easier to have this hybrid model. However, we noticed that you need to ditch a lot of cool stuff that is in the particular cloud in order to be cloud agnostic or to have the hybrid model. One of the easiest example is related to the networks and the firewalls that you have. So usually you try to isolate each application into the separate group of servers that have access to certain services. Now, when you are doing it on premise, usually you are doing the subnetworks for your network environment. You are just dedicating some addresses for this particular application, and then you operate on the subnet level when you are creating firewall rules about which application can connect to which service. When you go to the AWS, instead of managing the IPs themselves, you can tag each of your service with so-called security group, and then you just connect those security group together in order to have exactly the same setup in terms of security and the firewalls. Now, in my opinion, the tags, the security groups, this is a lot easier to comprehend, because if you talk with, well, developer or someone that is not working on the infrastructure per se, you are just saying that my web application security group wants to connect to web application database group, and that's something that's understandable, not that my 10.1 subnet wants to connect to 10.2 subnet. This is something that you need to have additional knowledge. Unfortunately, if you are trying to do the hybrid model, it's usually not that simple, and you need to resign from some of the abstractions that you can get with the cloud. And in many cases, the people that are doing the hybrid model are actually going back to the subnet routines, and they are creating those subnets in the cloud, which is possible, of course, and this will work. However, you are losing a lot of benefits of actually using a higher level of abstraction that is available in the cloud. So it's possible, definitely, if you are going to the cloud from on-premise and you don't want to do it with one shot, then having hybrid model, just moving gradually each application, still having the connectivity is something that's worth considering. However, in the long term, being in the one cloud and unfortunately being locked to the cloud provider, in my opinion, this is a way better and a way cheaper for the development cost perspective, it's a lot cheaper to be in one cloud and utilize all of the potential of the particular cloud.
Okay, so how about security in that case? So you are in one cloud, and let's say that you are in data center XYZ with Amazon, and then there is a huge piece of rock hitting Earth, and it wipes out this data center from the face of the Earth. But you don't have a backup in Google, for example. Like, is that the case? Like,
well, if you are building the data center, this is also something that you should be thinking about. So with AWS, you can really easily be protected against one meteor strike.
okay.
So every region of the cloud actually have multiple availability zones. And availability zone is a building that's usually located few kilometers away from each other. So this is completely different server room. And what you are doing is you are putting your application workloads into both of them. So in case the meteorite hits one of those data centers, you still have potential to be up and running because a lot of your hardware is in second one. If you have auto scaling, then probably it will just add more servers. Probably in this particular case, if everyone from first data center tries to spin out the infrastructure in second one, there will be lack of servers. However, the theoretical idea is that you will be able to survive such case. Also, when it comes to the cloud, it's worth mentioning that you don't have only one region. You can choose between Europe, US, and so on, and you can move the portions of the data. And for example, have your database backups not only in Europe, but you can move them to US, or if for some reason you cannot move the data to US, you can have multiple places in Europe where you just have your data backed up. So in case of really heavy meteor strike, you have those other regions that hopefully will be up and running.
If it's so heavy, you probably have different things to worry about
exactly.
than the security of your cloud, of your data or your application. But so I assume that all of those big providers give you that possibility, right?
Yes. So this is pretty
geo
standard.
Diversification, or how do you call it?
To be honest, I don't know what's the official name. With every cloud, you have multiple regions because they want to be close to the customers. So it's also important to choose the good reason for the customers that your application will have, because this will change the latency between the user and the application. So yeah, you have multiple of those regions, and in every region there are availability zones, and this is standard pretty much in every cloud.
Okay, you've mentioned backup and having this backup in a different place. I remember our conversation back in the day about backups and about the possibility of putting them back to life and so on and so forth. Do you think that backups are important, and if they are or they not, why?
I must answer this that they are not important until your application works. When it fails, then immediately backups became really, really important. And it's really good to make sure that those backups will be available at this point. And the conversation that you're referring to, there is actually a study showing that 75% or even more of the backups cannot be restored because of the way you are taking the backup and the corruption of the data that may happen. And this is pretty huge number. And I was actually hit by one of those in-house
75%.
Yeah, 75%. So we tried in one of my previous companies to restore data from backup, and after like week of trying, we just decided that it will not work out, and the backup was corrupted. So it's really important to also test your backups every once in a while. And with cloud, it's, in my opinion, a lot easier, because although you are not testing your backups particularly, however, if you have the database like the RDS in AWS, then at this particular time, probably someone is restoring his database. So the overall workflow of having the backup, of having the restores, is tested by millions of users, hoping that your will be working as well.
Okay, so it's not the case of the actual file. It's the case of putting this file restoring this file in a way so every piece of the puzzle should be in the same place.
Exactly. So if you are thinking about backups, then usually people are thinking about the backups that they have in home. So if you have pictures from the camera, you can just copy all the files and everything is okay, right? However, if you think about each picture as the individual customer data, and they have relations between them, and you cannot change one picture without changing reference in another. So if you'll be going through thousands of millions of those files, at some point probably there will be update that will change the whole graph of relations between those files. And this is something that you need to think about, especially if you are talking about databases and so on, that it's not that easy to just move the files around. And with AWS, for example, what is done is they are doing the snapshot of the disk at the particular time, and you know that you have the consistency of all the files, and then they are doing the backup instead of just coming in and doing the copy all the files and hope that they will work in the end, because you can end up with really corrupted data.
Okay. Do you think that there are any, best practices when it comes to how often should you back up your environment, your database, your files, like your users' data? Like, is it, of course, I understand that it differs between business and business, right? There are different workloads, there are different industries and so on and so forth, but are there any best practices that, in your opinion, should be taken into account?
So there's no one rule of the thumb for it. So it all depends on what is your data and what is your business. First of all, I think that for every production system, you should have redundancy. So in case of one server goes down, there is a second server that has the data up to date. And well, with, for example, RDS, so database in the cloud, you have this option to have secondary server that have exactly the same copy of the data. Now, when it comes to backup, it really depends on the system, because if you have system that stores historical weather information, this is something that you'll add data, you can probably restore it from some third party, and maybe not having the backup is not the ideal because you will have a lot of data crunching. However, if you do it once a day, it seems to be pretty okay, right? You will have to just go with 1 day of data in worst case scenario. However, if you are doing some kind of payment system and you have a lot of transactions, then having the data every hour or every 30 minutes may be a better solution, or maybe adding more redundancy to the places where you store the data. So you must think about the backup that if you are doing it once a day, then in worst case scenario, you will lose 1 day of your data. So you should tweak it to the level of how important your data is and how much changes you are doing to the data itself.
Okay. So yeah, I think that now I get the whole idea and the whole picture about culture, right? Because you have a lot of aspects during that process of, designing, shipping, maintaining, that, multiple people are involved in. So it's good to have different perspectives and different things, because I can imagine that lack of communication in terms of how many transactions customers are having or what is essential for their business can have terrible consequences.
Exactly. And in case you are separated from the team that designed the application, you usually get just the black box. So I have this database, I don't know what's in there, I don't know how important the data is, and well, I'm not sure what I can do with it. So probably I would go the safe way, and I will just add the redundancy and pretty aggressive backups just to be sure. However, in many cases, you can talk with the development team and even the customer that ordered the application in order to get the feeling what the data is and how important it is. And truth to be told, the best definition of system that is not critical, or the data that is not critical, that it's not critical until it's there. If it's gone, then suddenly it becomes critical data. And what I saw over the years is that in many cases when we start a new service, we say that, okay, this one is not that important for our business. However, we don't update this information. And usually we have those services that we think that, okay, they are not critical. And at some point we add the integration that adds them to the critical path of entire system. And if they crash, they can bring down entire system or entire application together with them. Now, this is really important to remember, and in many cases it is not that hard to make the system resilient to failure, but you have to have this information from the very beginning, and also whenever you are planning new features, also make sure that you use the correct way of communicating with those critical, non-critical systems, and it makes it a lot smoother.
And I think that's also a way to optimize the costs, right? Because if you know what's essential and what has to be backed up and what does not, so there are multiple angles to look at it, but it's the way to optimize.
Yes, it's an option for optimizing. I would be cautious about optimizing in cost in terms of resilience of the application. So it's really easy to come to the company, and I actually heard the rumor of the company that hired the guy to decrease the cost of their backups or the infrastructure, and what he did is he actually cut off the backups. And if you think about it, the backups can be really costly. So the naive way, if you have 1 terabyte of data and you are doing backup every day and you are copying all the data, if you have the backup for a month, you have 30 additional terabytes of just backup. And of course there are techniques to make it lower. However, it can be really costly. And of course you can go with this type of optimization and decrease the cost of backups and redundancy. However, what I usually do is I don't allow it on production. So all the code that I created or we created in the team for production environment, it will not allow you to disable backups. It will not allow you to disable redundancy. We can of course switch it off for test environment because we don't care about the data there. However, on production, we want to make sure that the customer data is safe. And even if we do any kind of error in the code, on production, there is absolutely no way to disable the security, the consistency of the data.
Okay. Do you think that infrastructure engineer plays also a role in application security?
Yes. So even the role actually shifted from DevOps to more DevSecOps, and application security is something that all the parties should think about, and this also includes the customer and user of the application. So but yeah, making sure that infrastructure is safe, making sure the applications are secured, and also training the users and making sure you are not like sending emails that can be easily phished, right? So if you're a bank, don't send information that hey, click here to update your info, because your bank will be probably vulnerable to this kind of phishing attack. However, security is on all levels, and I believe that yes, also the infrastructure team should be really involved in planning out the security of the system.
Did you have, or maybe you remember any examples from your past when maybe not something terrible happened, because that will sound cliche, but something happened that was like, okay, that was unexpected, security-wise, I mean.
Security-wise? Well, with security, I found out that in many cases, it's not about the deliberate action, but it's more about the mess that you have in the infrastructure, in the code. So when you are creating the first version of application, usually you know all the requirements, you just create it, a little bit of the waterfall approach, right? Customer usually knows what the minimal version should look like. And then you're coming in with additional features and you try to redesign some stuff, integrate with more things. And at this point, there is potential to make the initial design that was really pretty and really organized a little bit of a mess. And in here, it's really important to always close down the holes that you drilled for the previous part of your software. If you don't do it, it's probably a option to get into the application and to use it in a malicious way. So it's good to remember that, first of all, make sure that all the infrastructure and all the code is actually cleaned up and there are no loose parts in it, and it will make you a lot more secure, right? The second thing are, of course, being up to date with the dependencies that you have and so on. However, the first really important part is to make sure everything is tidy in the code.
Okay. So clean and tight, that's the way to go.
Yeah, for security, in most cases, the most scenarios that I saw were actually some leftovers that were not cleaned up after some features or
sloppiness.
Yes.
Okay.
So yeah, also there is this case which I try to emphasize, that whenever you have the application error on production, you should not think about it that it's something that we have to live with. You should also go into your monitoring and make sure that, for example, 500 errors, so the internal server error, is not occurring too often, because this means that somebody is reaching the place in your code where you have not validated the data or you have not added correct error checking. So this is always the potential for actually looking for a security breach. And a lot of the tools that we are using for doing penetration testing and this kind of security scans, actually what they do is they go through your APIs, they look for the error codes, and in case of this particular error, this is a red flag to actually go deeper and investigate what you can do with this particular error.
Okay, so it seems to me that you are an orchestrator. So you just sit, plug in the tool, start another tool, start another tool, because you've mentioned like 24 of tools today. So.
If it all would be so easy, yes, then then probably yes. However, when I'm talking about the tools, it's a little bit like having for example, with infrastructure. We are using the tool that is called Terraform. However, Terraform itself only manages creating, changing, and removing the infrastructure. You still need to come in and create all the configuration for it with the Terraform language, let's say, that will describe what you want to have there. And this is the part where we actually come in and we code this part of the system. The same goes with orchestrating the server. Of course, you have a lot of tools like, for example, Chef or Ansible that you can use to provision the server itself. However, again, somebody needs to come in and script what needs to be there. And of course, you have a lot of community stuff, and probably if you are just starting your business, you can take a look at those and say, okay, let's go with this one and this one. However, when it gets bigger, it's good to have a full knowledge how the system is built and make some changes that will make it fit to the application itself.
I'm not trying to say that you're not instrumental, so don't get me wrong. Of course you are. Even the simplest tools, and believe me, I've seen that with the simplest applications require some knowledge from users or some proactiveness to actually make it work. So I can imagine that it's not,
and experience, because with the tools they are not aware about the cloud that you are deploying to. So you need to know what are the pros and cons and strengths and weaknesses of the solutions that you are using, and this is up to you as the operator or the developer for those tools to actually create a valid infrastructure design and just use the tool to do the heavy lifting and apply the design to the cloud.
Okay, any situation, because I remember that you've mentioned within in the context of continuous work of the applications and environments, any situations that you can think of in which you were woken up in the middle of the night and it actually happened that it crashed and it was bad and it was stressful?
Well, I had a lot of such situations. When I began my work, I started as an intern in Sabre. Sabre is creating the software that powers the airlines. So probably a lot of the viewers actually use the software even not knowing that they are doing so. When they are entering the airport and going through the gates, all of the transactions go through, some go through the Sabre, some through other systems. And at some point I became a system owner for one of the critical systems there. And what this meant is that if we were offline for more than few hours, it will probably lock down airports that were using Sabre system as their primary backend. So this gives you quite a lot of stress whenever whenever your system goes down. The first hour was okay. The second and third, you got a lot of tension, and you saw those guys coming in and asking that if you'll be offline for 2 more hours, then we will sunset the United States airports, and that's not good for business. So yeah, we had plenty of situations where really weird stuff happened, and well, where you have servers and a lot of them, it can happen. So even the things that you may not think about, like we had the script that when it was starting up from the network drive, it was looking for the configuration on the same network drive, and based on this configuration, it was continuing its work. Now, what happened is that script was executed. In the very beginning of the script, during the couple milliseconds, the the network disk actually went down. So it was not able to read the configuration. And although you have like 100 milliseconds between launching and reading the configuration, the script crashed pretty badly because nobody thought that, well, this disk where the tool is and the configuration is can go offline in this particular way. So those are the really weird things, and well,
you cannot predict that.
You cannot predict that. And you should always, well, think about it, that everything, absolutely everything can go wrong on production.
Okay. You've mentioned that it happened a lot. So if you were to say, how often does this happen? Are you a kind of a firefighter kind of guy that once a month you at least, you get on your Saturday, you get notified? Or?
So it really depends. It really depends on the company and the application. So when I was working with big corporations and we had really big systems, a lot of traffic, and also there was no this DevOps approach. Then as a system owner or system engineer, first of all, we had rotations, the on-calls, so I had it like once a month, and during this week that I had this on-call, nearly every day I had to do something after hours, and maybe once a month I had a call in the middle of the night that I should check something and so on. Now, if we move towards the smaller companies, if you are doing it right from the beginning, then I don't recall any middle of the night call during the last year or so, or even longer. So you can do it the way that the infrastructure will be resilient and the application will be able to heal itself. And in this particular moment, you don't need to wake up just to click the button to restart it. It will do it on its own, and you will be needed only for really serious stuff. And if you do it right, hopefully the serious stuff will never occur.
Happen, unless the disk will burn down.
Of course, but yeah, with the disks, again, you can do a lot of stuff in the cloud that, for example, it will automatically ditch the broken disk, connect the new one, and restore the backup. And if you do it this way, then you don't need to wake up in the middle of the night. You will probably get some kind of warning. However, if during the 5 minutes it will not launch back again, then there's the moment for you to jump in. So this is the level of automation that you cannot do on the data center, where you have to physically go in and change the hard drive. But with the cloud, for you, it's just a service with an API. You say, I don't want this disk, give me a new one, restore this data and continue working. So that's the huge benefit that you have with the cloud.
That's interesting. Okay, so what do you think is the most interesting part of being infrastructure engineer? Because I assume that at some point in time you could switch. You could go back to being a developer, you could switch a technology or fish.
I think it would be seeing the world burn. So being the infrastructure engineer actually gives you this potential of seeing how applications behave with huge traffic and seeing where there's the limit of the systems that you have within your infrastructure. And those are the most interesting parts, right? Also, there are challenges that you can, if you are interested in those, you can pursue. For example, I like to look on the infrastructure from the cost perspective, and you can go with the safe approach and, for example, buy the servers for their full price. However, a lot of clouds offer so-called marketplace where you can buy servers for really cheap, even 1/10 of the price. However, there are some drawbacks of it. So, for example, this fleet of servers, they are usually the ones where there's still one big customer that's paying for one VM. However, 90% of VMs were actually moved somewhere else. But the AWS doesn't want to shut down the server because they will remove this customer and they don't want to do it. So they are offering the remaining 90% of the capacity for a cheap price. However, if this particular client that is using the server decided to migrate to another VM, then they will just shut down the server and you have like 2 minutes notice that your server will go down. And if you plan for it and you use the tools to utilize those really cheap servers, then what you can do is you can decrease the cost of the infrastructure by using those cheap servers. However, you need to get some grips of how this works and what you can do and which applications you can put there. So that's one of the regions. The second one is the auto-scaling. So going not to even 1, but even to 0 instances when there is no traffic and not paying at all for the infrastructure, and then quickly scaling up to hundreds or thousands of customers that are coming in. This is also really interesting part of being infrastructure engineer.
Okay, cool. Do you have any, mantras, funny stories, or anything that you would like to share with us?
I have a lot of funny stories, especially from the days when I was a system owner. Not necessarily for my application, but I was attached to many of the mailing lists with all the errors that happened. So when you think about infrastructure and when it fails, then you usually think about the stuff like a lot of traffic, maybe some database logs and so on. But it even can go further if you have your on-site server room. There was a situation when the guys were decommissioning a really old piece of the servers, and it was always used, always named by the funny name they used on the floor. And nobody noticed that 4 of those servers in this server room were actually attached to some other part of the system. And when they were shutting down, removing hard drives and so on.
Thanks for watching. That was another episode of Score Couch. I really hoped that you liked it. Let us know what do you think down in the comment section. Give us a thumbs up. Subscribe and let us know what would you like to see in the next episodes. Thanks for watching.